Example 4. A bucket weighing 5 pounds when empty is loaded with 40 pounds of soil and then lift 15 feet. Soil leaks out of a hole in the bucket at a constant rate, so that there are 30 pounds of soil by the end of lifting. Find the work done in the lifting. So there are two things going on here. The total work total, equals to work bucket plus work soil. So work bucket is an empty bucket is being pulled, which is case 1, a constant force. And work soil is a filled bucket is being pulled. And it's going to be case 2, force as a function of x. So let's work on that separately. So work bucket is integration from 0 to 15, because we're pulling the bucket up to 15 feet from the ground. And force is the weight of the object, which is 5 pounds, dx. And we don't need to worry about gravity because this is in pounds. If it was in kilogram, then we had to multiply this number with the gravity. Plus integration from 0 to 15. So we need to find f of x. So at the beginning, our bucket is 40 kilogram filled. So this point is 0, 40. And at the end of the 15 feet, when it is 15 feet, the bucket has 30 pounds of soil. So this point is 15, 30. As you can visually see, the function of x is linear function. So we have to make up the equation of this function. So we need to find the slope. We can find slope from delta y over delta x. Delta y, which is change in y, which is y2 minus y1, over change in x, which is x2 minus x1. Here our y2 is 30 minus y1 is 40 over x2 is 15 minus x1 is 0. It will be negative 10 over 15, which simplifies to negative 2/3. So this is our slope. So our equation is y equals to negative 2/3 x, and our y-intercept is 40 plus 40. So this is the equation of the force as a function of x. So we're going to plug in here negative 2/3 x plus 40 dx. And if it was in kilogram, we had to multiply this whole function by the gravity. But here we're not doing that because it's in pounds. So work total equals to integration from 0 to 15, 5 dx plus integration from 0 to 15, negative 2 over 3x plus 4d dx. And you're going to take the antiderivative of these functions and plug in upper and lower boundaries. So I would like to leave this question here. I'm leaving the rest to you because it's very easy. It's easy to find the antiderivative of 5 and antiderivative of these two functions.